Topic Lesson 7.3 Trig Functions and Real Numbers. The essential questions. How is the unit circle related to trig functions? So unit circle is a very big topic, and that's the reason why you want to memorize it if you're going to take higher level math next year. If you're taking the math analysis, if you're taking the pre-calculus, or even later on you're going to take calculus, the unit circle is going to be a very helpful tool. So you want to be able to quickly do this type of trig functions. So unit circle is almost like a multiplication tables for numbers in trig functions. Now let's take a look at example number 1. What are sine and cosine of angle 2 pi over 3? And again, let me bring you up with the unit circle graph again. So as I mentioned, you want to be able to memorize it so that you don't have to rely on using the Pythagorean theorems. So where is 2 pi over 3? 2 pi over 3, as you can see, it's going to be this angle measurement here, 2 pi over 3. 2 pi over 3. So that's where we're going to start our example number 1. And I also copy over the coordinates. So 2 pi over 3, you will have a coordinate of -1/2 and √3 over 2. So this is the angle 2 pi over 3. So do you remember that we mentioned for sine, it's going to be the coordinate value for y, which is, what's the coordinate value here? √3 over 2. Cosine is going to be the coordinate value for x. So this is unit circle. You can directly apply this result to find the answers. If it's not a unit circle, then you have to calculate using the Pythagorean theorems. So when it comes to unit circles, it's pretty handy. Sine is going to be the y coordinate. Cosine is going to be the x coordinate. And then tangent is y over x. And that's the reason why you want to memorize the unit circle. Example number 2. So one thing I like to mention is you kept seeing me write the sine theta. So I pronounce it as sine theta. So don't ever pronounce it as sin. Okay, I have students in my pre-cal. I'm not sure if they are trying to make fun of it or just to be silly about it. This is pronounced as sine. S-I-N-E, sine functions. Okay, so even though it's written as S-I-N, it doesn't pronounce as sin theta. Okay, it's pronounced as sine theta. So that's something I would like to clear out first. Example number 2. What is sine theta if cosine theta equals -3 over 5? And it is in third quadrant, quadrant 3. So this is no longer in unit circle. How do I know? So first thing, the first clue that I see is it doesn't have a denominator is a 5. So let me bring out the unit circle thing here again. So do you see any number that's with a denominator equal to 5? It doesn't look like there's any number here has a denominator equal to 5. So that's the first clue. I can tell that it's not going to be a unit circle for this example. But that's okay. We're given the information of third quadrant. So what do I do? First thing, I like to make a sketch. Remember, when it comes to the geometry questions, I like to make a sketch for myself. It's in third quadrant, right? And the cosine theta, do you remember I said it always reference to x-axis? So do you see that I am drawing this line to the x-axis? I am never ever going to draw it to the y, okay? So I'm just making dot here. So don't ever do that. Don't ever make your angle with reference to the y. We're doing it to the x-axis. So I'm emphasizing it here, x-axis. So that means this is the angle measurement theta here. And we know that cosine is -3 over 5. -3 over 5. So we have the adjacent side as -3. We have the hypotenuse as 5. So how about the opposite side? Opposite side, how do I find it? So I'm going to use opposite the hypotenuse theorem, Pythagorean theorem, Pythagorean theorem, which is 5 squared equals negative 3 squared plus y squared. A squared plus b squared equals c squared, right? So 5 squared equals negative 3 squared plus y squared. So that gives me y squared equals 16. So that means my y is going to be 4. And do you see that it's in fourth quadrant? So should my y value be positive or negative? Of course, it has to be negative, right? It's in third quadrant, so my y value would have to be negative 4. Y should be negative 4, or this coordinate number is going to be negative 3, negative 4. Once we have that, do you think you can figure out the sign? So sine theta is going to be opposite over hypotenuse. Opposite is negative 4 over hypotenuse. Move on to example number 3. What is tangent negative 5 pi over 6? What's tangent negative 5 pi over 6? So do you see that the angle measurement negative 5 pi over 6? What's negative 5 pi over 6? I think I mentioned this in the lesson 7.2. When you are making the angle measurement from the initial side and you go in counterclockwise, the angle measurement is going to be positive. If you start from the initial side and counting from in the direction of clockwise, it's going to be negative angles. So that means that tangent negative 5 pi over 6 is going to be measuring in clockwise directions. So once again, let's take a look at the unit circle here. So where is 5 pi over 6? So as you can see, 5 pi over 6, if I measure it in the counterclockwise direction, it's going to be this way, negative 5 pi over 6. So if you take this opening, and do the same thing, but instead of going counterclockwise, you go clockwise, what will you get? So the same opening, so it will be this one and this one. Do you see that? It's the same openings, but instead of measuring it counterclockwise, you are measuring it clockwise. So we're going to take this number, negative root 3 over 2 and negative 1/2. Negative 3 root 2 over 2 and 1/2, negative 1/2. Bring it over. Okay? So I'm just going to make a sketch for myself here. So hopefully by me showing you how I get these numbers, you'd realize that it's because of the directions, it's a negative angles. So negative root 3 over 2, negative 1/2. So what's tangent? What is tangent? Tangent is defined as opposite over adjacent, or y over x. Y over x. And since we have the coordinates, so negative 1/2 over negative root 3 over 2. So negative over negative becomes positive. So I'll quickly do this, make it become positive. And do you see that they have the same denominators? Same denominator, 2 and 2. So I can reduce them down to 1 over root 3. But that's not what we leave the answer with when it has a irrational number at the denominator. What do we normally do? We rationalize it, right? So we have to multiply top and bottom with root 3 over root 3. 1 times root 3, so I have root 3. Root 3 over root 3 times root 3, that's root 9, and root 9 turns into 3. So the answer for tangent negative 5 pi over 6 is going to be root 3 over 3. It's in third quadrant. So negative over negative become positive. If you have any questions about the trig ratio, trig functions, unit circles, please send me a note. Then I can try to explain it maybe in a different way or refer to something you want to think about for this topic. And that brings us to the discussion of Pythagorean identities. As I mentioned in 7.2, we're going to talk more about the identities in pre-calculus or math analysis. But here, this is a good time to show you or bring your attention to the Pythagorean identities, as we've been trying to find the answers for these examples using the Pythagorean theorem. It's not a coincidence that these two have the same name, Pythagoreans, because it's the same concept. And that is sine squared theta plus cosine squared theta equals 1. Sine squared theta plus cosine squared theta equals 1. And if you think about the unit circle, it does make sense. Sine squared theta plus cosine squared theta, it's inside the unit circle. So whatever you have here, the x and y values, as you take the square of each side, x squared plus y squared equals what? X squared plus y squared, does it equal to the hypotenuse here? And we have a radius of 1, so that means it's going to equal to 1. So this is just a quick explanations or demonstrations why the Pythagorean identities equals 1. Sine squared theta plus cosine squared theta equals 1. And we're going to talk about its variation later, again in math analysis or pre-calculus later. So this is just a quick lesson on the identities that you're going to encounter later on. We're going to learn more later.